It's time for lowercase u, uppercase R, uppercase P, uppercase F, otherwise known as Unicast reverse path forwarding. You'll sometimes see it represented this way. Don't be surprised if you see it all as upper caps. Doesn't matter how you present the acronym. What is important to us is that we master exactly what's going on with this particular technology. You probably recall speaking of reverse path forwarding a lot when we were talking about multicast traffic. Remember what multicast will do. Multicast has a very simple loop prevention mechanism that says, does it make sense for the particular multicast feed to be coming in that particular interface? We're going to do the same thing, but for unicast traffic. Why would you do this? Well, you don't want IP spoofing to take place inside of your environment. This is when an attacker will falsify their IP address, maybe to get past one of your access control lists, for example. Or maybe you have a device that is on the edge of the World Wide Web and you don't want attacks being utilized from IP addresses that make absolutely no sense. Have you heard of this before? They're called bogons or Martian addresses. And what would make no sense for a source address coming from the World Wide Web? How about our RFC 1918 addresses? Sure, we shouldn't see traffic coming in from the web at a 10.x address as an example. Or how about a loopback address? Or how about the all zeros address? Or how about the all 255s address? Sure, you could create really complex, difficult to maintain access control lists at edges of your network to try and guard against this, but why not automate it with the Unicast reverse path forwarding feature? Like so many powerful features with Cisco systems, this is just so easy to configure. I'll go to R2 here and let's pretend the fast Ethernet 0/1 interface is connecting out to some untrusted portion of the network or maybe even the World Wide Web itself. So we go to the interface, fast Ethernet 0/0. Whoa, now I love that I just did that. Always verify you are at your correct interface. In the lab exam, if you're struggling with this, you might want to go ahead and draw out a quick diagram on your scratch paper of your scenario, then take the pen or pencil and point it at the interface physically that you need to be working with so you can make sure you're applying things to the correct interface. There is nothing more frustrating than failing something like the CCIE lab exam because you put in the perfect configuration, but you put it in the wrong spot. We're going to do IP verify, then I'll start using my context sensitive help. Only one option here, and it's for the word unicast. Great. Then we have reverse path, which is an old, soon to be retired command format, so we don't want that. So we're going to say source, reachable via, and now we get into the two forms of unicast reverse path forwarding that we can configure on this device. If we say any, we are doing what is called loose unicast reverse path forwarding. What this means is if that source address makes sense in our routing table from any of our interfaces, then go ahead and permit it. Or we can do strict, which is the RX keyword. This says, okay, wait a minute here. That source address has to make sense for the very specific interface, fast Ethernet 0/1, or we drop it. Even if that source address makes sense from one of our other local interfaces, do not let it in. Notice there are other advanced options like allow self-ping, allow default route to be checked. You could put up access lists to make exceptions to this unicast reverse path forwarding logic. For our purposes here, we just, let's say we're reading the exam scenario and it says, you're worried about bogon traffic from the internet on R2's fast Ethernet 0/1 interface, and you want to make sure that source addresses make sense for that specific interface, well then we would know this is all we have to do. Notice how I gave you a scenario there where the lab exam doesn't tell you set up strict unicast reverse path forwarding. That's a favorite feature of the proctors with the lab exams. Remember, they'll say what they want in plain English, never telling you it's URPF, never telling you that it is strict mode that you want to configure. They rely on your knowledge of the feature sets in order to do that interpretation. So we end this configuration, and obviously what we can do is we can go out to R3, send some weird traffic in, and verify on R2 that the unicast reverse path forwarding feature stopped it. So on R3, let's do this. Let's configure a loopback of something evil like 666, and we'll say IP address on this interface is, let's do a 10.x, 10.10.10.66.255.255.255.0. We then ping across R2, and we source it from loopback 666. Now, it's not going to work, but let's face it, this is probably more of a factor potentially of reachability across the devices. So what we clearly need to do is go over to R2, and we need to verify that it was indeed the verify feature that caught it. Here's how easy it is to do. Do a show IP interface for the interface where you configured unicast reverse path forwarding. At the bottom, you'll see the IP verify source reachable via RX statement here, mirroring what we configured for this particular interface. We know that's strict URPF, and notice there are 5 verification drops. So the traffic did not make it across R2 in its journey to R1, thanks to the configuration of our security feature. So reverse path forwarding, it's not just for multicast anymore. In this nugget, we took a look how we can use it for unicast traffic as a powerful security feature, particularly in the area of anti-IP spoofing. We examine the source address and ensure that that source address makes sense per our routing table. We do it in a strict fashion against a particular interface or in a loose fashion against all of the interfaces on the particular device. And again, what they're feeding the underlying unicast routing table. I sure hope you found this nugget informative, and I'd like to thank you for viewing.